So as promised, I'm taking a look at a function that's going to involve both vertical and horizontal transformations. This is a transformation of tangent. So again, I've drawn for reference just one period of tangent over here. Usually when I'm asking you to graph, I will ask for at least 2 periods because I don't want you to start thinking that this is the entire graph. This is just one period. It repeats itself, so it goes on forever and ever and ever and ever, as all trig functions do. But if I can figure out how this one period gets transformed, then I know it just repeats itself again and again and again. Okay. All right, so everything I do before I plug into tangent is going to affect things horizontally. So let's start by working with that. So I know that tangent does its thing as the input varies between negative pi over 2 and positive pi over 2. So I'm going to solve for x, and what I get will be my new beginning and ending points. So I'm going to divide everything by pi. That's equivalent to multiplying by 1 over pi, which is kind of nice because those cancel. So I get negative 1/2 is less than x minus 1/2 is less than 1/2. Now I'm going to add 1/2 to each piece. And so I get 0 is less than x is less than 1. Okay. So I can see that my new period is ending point minus starting point, which is 1. That should be the same as if I take the old period and divide it by the number that I was multiplying by x, which is pi. Well, the old period was pi, divided by pi is 1. It works. I get exactly the same thing. Okay. Now, that means that the new increment is going to be 1 divided by 4. Okay. So, kind of nice. I'm going to start at 0. I'm going to count by 1/4 until I hit 1. I think in order to do that, I'm going to erase, actually, I'm going to just remember that information. I'm going to keep that up, keep up the function that I'm graphing, give myself some space to draw the actual graph. Okay, so starting at 0, we said we were going to count by 1/4. So 1/4, 2/4, which will reduce to 1/2, 3/4, and then 4/4, which will reduce to 1. So that was my new starting and ending point. I know I start and end at an asymptote. If I'm going to draw a second period, I'm just going to keep going. So I would hit 5/4, 6/4, which is 3/2, 7/4, 8/4 is 2 pi, and there's my next asymptote. So now I need to figure out what happens with my y values. Well, this is what's affecting the y values. I'm multiplying by 3. So I'm going to say, okay, the first point that I plotted was at -1. Now, if I multiply that by 3, it's going to be down here at -3. The next point I want to plot corresponds to the point that's halfway in between my asymptotes. There, the y value is 0. 0 times 3 is still 0. Then the next point I plotted corresponded to halfway between the 0 and the asymptote. That's going to become our 3/4. It was at 1 times 3 is going to put it up here at 3. And then I can play connect the dots. And then I just want to copy that again. First point that I plot is at a low value of negative, well, low-ish. It gets lower. Then 0, then 3, and then play connect the dots. Okay, so there's our transformation. Excellent. We've got one more video for this section. It's going to be similar to what we did with sines and cosines. When you come back for the next video, I will have some graphs on the board, and we're going to try to come up with the equations for those graphs. See you then.